Welcome back to class. We're doing 7.3. Hopefully you had a little bit of fun yesterday working with Desmos and actually being able to manipulate those graphs and change them. And hopefully that helped you understand the information. Yesterday was pretty much a review of first semester when we talked about intercepts, domain, range, max, and min. That's all stuff we talked about last semester. Today we're going to do a little bit more of the same. We are going to use our graphing calculator, though, to help us out. So today, you will further investigate additional quadratic functions in standard form with the aid of a graphing calculator. Recall that the graph of a quadratic function is a parabola. We'll discover if all parabolas have the same characteristics, such as x-intercepts, y-intercepts, vertices, and lines of symmetry. The calculator directions that you will need for today's lesson are listed below. So, on the calculator, we are going to use, let me just move this up here. We're going to use the y equals function. So that button is right here on your calculator. We are going to use the graph button, which is right here on your calculator. And then we're going to use the second button, so the blue button. And if you know how to do that, you'll be good to go. Also, just in case you are unsure of it, we're going to need the x squared. And that button is diagonal from the 7. So it's down here, it's the x squared. And then the x button is right here, right next to the green one. So we're going to hit this to get x, and then if we want it to be squared, we're going to hit that button. And you guys will see what we have to do for that. So step number 1, the first thing we're going to do is we are going to put that equation, this x squared minus 2x minus 8, into our calculators. So I would always start with step number 1 on your blue sheet, which once again, we're going to keep using the calculators. So make sure you keep those blue sheets with you. Step 1 is to reset the calculator. That's going to be second plus 712. And once that's done, we can start with these calculator instructions. So we're going to press y equals. So it says press y equals and type your equation into the calculator. So let's type it in. So remember, we hit this button right next to the green one for x. And then we want to hit x squared. So we're going to hit the squared button. Perfect. Also notice we don't have to type in y equals because it's already there for us. So we've got y equals x squared. Then we have to do minus 2x minus 8. Also make sure you guys are hitting the minus button. Let me show you. You're hitting the minus button on the calculator, not the negative button, because your calculator does think those are two completely different things. So make sure that when you're doing it here, you're using the minus button, not the negative button. All right, perfect. So press graph to view the graph of your function. So I'm going to hit graph. And there is my parabola. And we're going to sketch that in just a bit. And it says press second graph and complete the table below for the indicated values. So we're going to hit second graph to get a table of values. Now notice my table starts with 0. But the table on your packet starts at -3. So I just have to hit up a couple times so that I can see -3. And once I have that, I can just copy down the table. So here you guys just copy down the table. So 7, 0, -5, -8, -9, -8, -5, 0, and 7. Perfect. Once we have that, we can start plotting the points. To plot the points, you guys can use the graph from your calculator or just graph the points. It's probably easier to just graph the points right now since we are graphing it and not sketching it. So there is the graph of my drawing. And if we want to go back to see the graph, all we have to do is hit the graph button. And it does match that pretty well. Right, so let's answer the questions. Number 1, label the vertex of the parabola. Remember, the vertex is when it starts changing. So here we're going down, 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 and then boom, we start going up. So that's going to be my vertex. And that point is 1, -9. There's my vertex, 1, -9. Next thing it says, draw a line of symmetry and label the line of symmetry with its equation. So remember, the line of symmetry is where it flips, or where we can fold it in half, and each half will lay on itself. Think of it as putting a mirror up to it and in the reflection. So it's going to go right down the middle, and it's always going to go right through the vertex. So it's a line straight up and down, and it's going to go right down through the vertex. We usually draw a line of symmetry as a dashed line, not a solid line. We do want to label its equation. The equation is always going to be x equals, and it's going to be where it passes through. So x equals 1. So there is my line of symmetry with its equation. Next thing we need is the x-intercepts. So remember, x-intercepts are where it passes through the x-axis. So we've got the x-intercept right there, right there. Usually there's 2, but not always. There could be 1 x-intercept, or there could be 0. And so those coordinate points are -2, 0, and 4, 0. We also need to label the y-intercept. So the y-intercept is right here, and that's going to be 0, -8. Also did just some color coding real quick. So my vertex is in yellow. You can see it in the table as well. My x-intercepts are in orange. Once again, you can see it in the graph as well as in the table. My y-intercept is in green. Once again, you can see it in the graph as well as the table. Make sure it says the directions say label them and circle them in your table. So make sure you circle them. I highlighted them. If you've got highlighters, feel free to do that as well. But if you don't, just go ahead and circle them. So question F, is this a function? Remember, if it's a function, it passes the vertical line test, which means I can draw a vertical line through any point. And as long as it only passes through 1, it is a function. So yes, this is a function. And our reasoning is passes the VLT, or the vertical line test. So you guys can see that. So yes, it passes the vertical line test, the VLT. What is the maximum of the function? So how high does this go? You can see the arrows on the end. It's going to keep going up, up, and up. So there is no maximum. Remember, if your maximum is infinity, it never actually reaches infinity. So therefore, it's going to be no maximum. And the minimum is going to be my vertex. So how low does it go? And it goes all the way till -9, but it won't ever go below -9. So minimum is -9. And question H, what is the domain and range of your function? So for all parabolas, the domain will always be all real numbers. And my range is going to have to do with the max and min. So I can see that the minimum is -9, and my parabola goes up, goes above -9. So all my y values are going to be greater than or equal to -9. And there's my range with that one. So hopefully this is a good review for you. We are going to continue on to the next page, and there will be questions in that video to check for your understanding. If you do have any questions, just look back at this front page, and that should help you out